Okay, we are going to start talking about inequalities and how to solve them. Before we start talking about inequalities, though, I want to make sure that you guys are familiar that you already have a good standing on how to do and solve inequalities. Inequalities are just like solving equations. This is an equation. So what you do to solve this is pretty much what you're going to do to solve the other one. The difference is that equals looks like an inequality, but you solve it the same way. So that means in terms of this, I need to isolate the variable x by subtracting 4 from both sides. So I'm going to subtract 4 from this side, subtract 4 from that side, and I have to subtract 4 from the other side, which means on this side I'm going to have left x is isolated equals 14 minus 4 is 10. So if you can do that, you can solve inequalities. We'll go into further with that, but let's make sure that we can do these problems. This particular problem over here is x plus 48. So I'm going to subtract 48 from both sides. Subtract 48 from this side, subtract 48 from this side. That leaves x on this side. And 32 minus 48, they are different sides. The bottom number is bigger. So I really have to do 48 minus 32, which is 16. And I have to think about which one is the bigger number. So that's a skill we've already worked on to make sure that you know what I'm telling you. In this particular instance, I am doing 32 minus 48. Well, I'm looking at that and I'm going, I can't. There's not enough. So they're opposite. This is a positive 32 and a negative 48. So I'm just going to find the difference between them, 32 or 48 minus 32, and I get 16. But then I have to think, oh, this number is further from 0. So the answer to this one is negative 16. Okay, so same thing here. This is division, or this is multiplication. So in order to isolate that variable x, I'm going to divide both sides by 5. So this side is divided by 5. The other side is going to be divided by 5. So I'm left with this x is isolated equals 80 divided by 5 is 16. Solved. So far, again, we're doing just fine. This means it's a fraction, x divided by 4, x divided by 4, x over 4. So in order to clear that, I have to multiply both sides by 4. And multiply by 4. You get x isolated on this side. X equals negative 7 times 4. Well, I know 7 times 4 is 28. But it is negative if I follow my rules of multiplying integers. Okay, let's go to the next problem. Number 5. So we have 13 plus x. So I need to isolate this x. So I'm going to subtract this 13 to move it to the other side. So subtract 13. Show you where I'm subtracting the 13. Subtract 13 from the other side. And you're left with, on this side of the variable, 13 minus 13 is 0, so all that's left is x. The other side is 56 minus 13, so if I did that right, 6 minus 3 is 3, 5 minus 1 is 4. So if my answer is correct, I get 43. Again, this is all very familiar. Let's do this last one right here. This one is negative 12 times x equals negative 144. So in order to isolate this x by itself, I'm going to divide both sides by negative 12. That moves it over to the other side. So divide by negative 12. Once I've done that, negative 12 divided by negative 12 is 1. So I just have x left over here. Then negative 144 divided by negative 12. Negative divided by negative makes it a positive. So 144 divided by 12 is 12. So if you can do this, you can do the next page. So let's go to the next page and take some notes. Well, let's listen to some notes. So solving inequalities using addition and subtraction. So far we're just concentrating on addition and subtraction. You can, just like I told you, you can solve inequalities in the same way that you solve equations. Use the inverse operation. So those opposite operations, you're going to use them to get the variable isolated, get it by itself. Same thing I said in the last page. When you add the same, I don't know what's happening there. So undo. When you add the same number to each side of an inequality, the inequality remains true. So just like an equal sign, if I have a -4, I'm going to plus the 4. I'm using that inverse operation again. And that isolates this x and leaves the answer to the other side. So we're going to practice. We're going to try this one right here. X plus 7 is greater than or equal to 19. So that will mean I'm going to subtract 7, just like I did before. Subtract 7 from both sides, which will leave me with x on this side. And I've got to do that greater than equal to sign. So insert special characters, greater than, and it is right here, rest. See, click it once, shows up. Done with that one. And 19 minus 7 is 12. We've solved it, just like you did the first page. Got this. This is cake. All right, let's keep going to the bottom one and make another practice. So we are doing number 2 right here. So t minus 5 is less than -7. So we're going to do exactly like we did before. We're going to use that inverse of subtracting 7. Subtracting 5. We're going to add 5 to both sides. Okay. This side, well, -5 and a +5. All I have left on this side is a t. And I can keyboard this sign. It's on your keyboard. Look for it carefully. -7 plus 5, they are different. See, this is a negative and a positive, so I have to use that 7th grade think. Since they're different, I'm going to find the difference. I'm going to subtract 7 minus 5 is 2, and then I'm going to think which one is further from 0. So the -7 is further from 0, so it wins, and it stays the sign. Did number 2. Look, cake. Good. Y'all got this. Okay, this one right here. It looks a little different because they flipped the variable to the other side. But does that really matter? Not really, because I really still want to get him all by himself. I want to get that variable isolated. So I'm going to add 3.6 to both sides. It's just going to look funny. So I'm going to add 3.6 to this side. And I'm going to add 3.6 to this side. And what I want you to notice, hopefully I can put my little buttons here. What I want you to notice is the fact that when you do this number, they are gone. So the only thing left is z and this less than sign. And 1.4 plus 3.6 is a total of 5.0. So your answer to that one, you will be able to type as, get in the box, 5 is less than z. Now I know that some of you are going to want to flip it around. If you flip it around, you got to flip around this. You got to flip the sign too. So that's why I'm just saying try not to do that unless you're really careful, because that's a really easy way to make a mistake. Just because the z is, if you're going to flip, then this has to flip. So we have one last word problem right here where my face is. See? The school auditorium seats 350 students. There are 309 students already seated. Write and solve an inequality that represents the additional number of students that can be seated. So basically, what's the maximum amount of kids? Okay, so the maximum amount of kids that they can have in there is 350. So that means it has to be less than 350. They don't have 351 seats for these kids. So if I was doing this, I have 309 kids seated, and I know that 309 is less than 350. So what they want to know is how many more can be seated. So more means plus, and n is the unknown. So your typed answer, assuming my thing will let me, will be 309 students seated. Whoa. Add the unknown number of students has to be less than the 350 kids or 350 seats. So these are your notes. There's going to be a page where I want you guys to practice this. At the bottom of that page, it has a little note. So I want you guys to pay attention to that note. If that note is there, if that note is not there, then I've made changes to the lesson. But for big picture, if you can do page 1, then you can do page 2.